mathematicious. It makes me so ambitious. My answers are judicious. Calculator never glitches. It's my mission. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicious. 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 Hold up. Check your word.
Hey Algebra 1 students, welcome back to Algebra 1 Big Ideas. We're in 5.7 Systems of Linear Inequalities. So last time on 5.6 we were looking at just graphing the inequalities. Now we're going to be looking at a system which is going to combine two inequalities together. So basically we're going to have two lines on one coordinate plane, two shadings on one coordinate plane, and we'll be looking at the solution set there being where the shading is going to overlap. So that's what we'll be checking out today. So we're going to be checking again. Start with just checking some solutions of those linear inequalities, just like we did last time. And then we're going to be graphing the systems. And then after that, at the very end, we'll be writing systems of these linear inequalities. So first of all, let's go ahead and look at our little cartoon. So a turtle outside of his shell. Dang, locked my keys in the house. Boy, I hate that. I always make sure I don't try to lock my keys in the house. That is a bad situation to be in. Alright, so now we get into our systems of linear inequalities. If you look at your journal book on page 164, page 164 has the vocabulary, and we'll start there. So our first vocabulary here is just what a system of linear inequalities is. So you can write down what I underlined here, that it's a set of two or more linear inequalities in the same variables. So this is an example, and you can write this example down there, just right there underneath that description of what this is. So these are two inequalities. They're in the same two variables. They're both in x and y, and they're both linear. They're both linear inequalities, just like we were doing last time. We were graphing just them separately. Now we're going to graph them together as a system. The second one that you can write down as well is a solution of a system of linear inequalities. So what the system is, what is a solution of that system? Well, much like the solution to just a linear inequality, the solution to the system of linear inequalities is going to be an ordered pair, and it's an ordered pair that makes both systems true. So basically, you can write this down, I underline it here, an ordered pair that is a solution of each inequality in the system. So if this is our system, then the ordered pair would need to be making this one a true statement, and it would need to be making this one a true statement. If it makes both inequalities a true statement, then it's a solution to that system. But if it makes only one true and not the other, then it's not a solution to the system. Alright, so we go ahead and you're going to copy those down first. We'll go on to our next part, which is just to identify some solutions. Tell whether the ordered pair is a solution of the system of linear equations. Or not, sorry, not inequality, inequalities, sorry. We're talking about inequalities here. We often talk about equations so much that it almost seems just commonplace to say equations. So the ordered pair that we're trying to check is this one in front. So this one's a 0, 0 ordered pair. And it's much like when we were checking the test point. You can check test points always to verify if your graph is correct or to figure out which side to shade. So it's like checking a test point, and we're testing this 0, 0. Is it a solution to each one? So I'll go ahead and do a couple here. I'll go ahead and do one. Actually, I'll do 3 and 4, and you can come back and do 1 and 2. So I'll do 3 and 4 here, and then you can do 1 and 2. Or maybe I'll do, yeah, that's fine. Actually, I'll do 1 and 2. You guys can do 3 and 1 and 4. So 2 and 3 is what I'll do. Sorry if I'm being confusing. So I'm going to start with this one here, number 2. -1 for x. Remember, this is our x and this is our y. So we're going to plug in. On this one, it's just got a y, so it's going to be 1. So I'll do this one over here. So 1 is our y, and it's less than 3. Is 1 less than 3? So far, yes, that is correct. Checks out. So far, it works for the first one. Now let's check this second one to see if it works for this one. So y is 1 still, so 1 is greater than, and then x is negative 1. So negative 1 minus 4. And so 1 is greater than, this is going to become a negative 5. So is 1 greater than negative 5? Yes, it is true. So since both are true, so since both of these got to check, then we can say definitely yes, this ordered pair is a solution to this system. All right, let's go ahead and try number 3. So for number 3 on this first one, we got 2 is x, 3 is y. So the first one here, we'll say first this is y, so it's going to be 3 is greater than or equal to, we got 2 plus 4, so 2 plus a 4. So 3 is greater than or equal to 6. Is that true? Is 3 greater than 6? No, that is not true. So right off the bat, we can see our answer is no. So since this was a no, the whole thing is no. So no, this ordered pair cannot be a solution to the system because it wasn't a solution to the first one. It has to be a solution. It has to check out for both of them. It has to be true on both. All right, so go ahead and pause the video and then do number 1 and number 4. So do 1 and 4 and then play it just to check your answers to see if you're correct. All right, so hopefully you finished 1 and 4. Now you're just checking your answers. So for the first one, we're going to just put 0 here. 0 is greater than 2. Is 0 greater than 2? Obviously not, so no right away. So right off the bat, you should be able to see that number 1 is no. When we come to 4, so 0 is for x, 4 is a y, so we'll start with this first one up here. So the first one is going to be 0, all right, sorry, now 4 is first, y is 4, 4 is less than or equal to, this would be like a negative 0, which is just going to be 0. I'll put the negative 0 though, but that just becomes 0, 4. So 4 is less than or equal to 4. And so far that's true because 4 does equal 4. It's got the little equal to on that one, so it works on this one. Let's go ahead and check this one down here. So again, start with 4. 4 is greater or equal to 5 times x. So x is 0 on that one, minus 3. So 4 is greater than, this is going to be 0. So 0 minus 3 is negative 3. So 4 is greater than negative 3. That is also true. So because it's true on both of these, you got to check on both of them, we can definitely say yes for number 4. All right, let's move on to the next part. So this is number 5 and 6. We're going to be looking at the graphing ones now, so let's go ahead and check that out. So back on your page 164, there's one more vocabulary that says graph of a system of linear inequalities. And what you can write there next to that one, you can just write that it's the graph of all the solutions of the system. So the graph of the system, graph of a system of linear inequalities is the graph of all the solutions of the system. And then right below that is a core concept. And what you can see on this core concept is we have two linear inequalities shown here. This one's a dashed line, this one's a solid line, just like we were doing on the last section. Now we need to graph each of these. So we graph the boundary line, and you could just do one at a time. So if we start with this first one, we would do the dashed line. And we could say this one's y is going to be, if I put 0 here, y is less than 2. So less than 2, the shading here is kind of the blue shading. It's going to go down below. This one here, it's in red, says, okay, we draw the boundary line first. It is a solid boundary line. And for this one, if we put 0 here, it's just going to be y is greater than negative 1. Greater than negative 1 is going to be up on this side, so that would be shaded in red. So red is going up here. So there's an overlapping shading, kind of like this purple section right here, where the blue is overlapping the red, kind of creating the purple section. That section right there is the solution section. That's the intersection, they call it. Find the intersection of the half planes. So the intersection is this part right here. So I'll go ahead and write down, this is our solution region, we can call it. Solution region is where the two shadings are overlapping. Okay, so that is the solution region is where the two shadings is overlapping. All right. So let's go on and try some now. We have a couple to try there at the bottom of 165. So let's take a look at those two. So again, before we get to that one, let's just take a look at this here because we can kind of see again with the colors. They have nice colors on this. So you can see again, here's the first one, y is less than or equal to 3. That's the straight line going across. It is solid. And it says that it's less than 3, so the blue shading is going to go down below here, just like we were doing last time. And then this graph, we're going to graph it also in the same coordinate plane. And this is the dashed line that's red going up this way. So we graph the boundary line, just y equals mx plus b, starting with 2, and then it's a slope of 1. And for this one, y is greater than 2. I put 0 here for x. So y would be greater than 2. Greater than 2, so this would be at 2 right here. Greater than 2 is up above. So the red shading has got to be over here on this side. And then here is the overlapping part. So again, that is the solution region. The purple section right there is the solution region. That's why they took a point out of that section, this -3, 1, and they're going to show that they can check to make sure that that is the solution region. You can just use that as a test point just to double check. The solution's the purple shaded region there. And they check that point of -3, 1, and it's checked for both of them just like we did on 1 through 4. It is a solution, so yes, that verifies that that's definitely the solution region. Now here's another one that's kind of interesting. This one, the first graph here, is a dashed line that's going to be blue. I believe that's the blue one. -1, yeah, it's going through -1. So the blue one here is the first inequality, the second one's in the red. They're both dashed lines, but as we would do this one, as we put maybe that over here, it's basically going to say y is less than -1 on this one. It's going down here, so it's shading on this side. This one, it's y is greater, it's on this side. Now you notice these two lines have the same slope, so they are parallel lines. And what you notice here is there's no overlapping region. There's no purple part. So if there's no purple part in this situation, you can see what they're going to say, probably figured out, there has no solution. The system has no solution when there's no overlapping part. Now if it was the other way around, if these inequalities were switched and maybe the red is going this way, the blue is going this way, then the in-between part here would be the solution part. So you might have a purple part in between these two lines if the shading was going to go the other direction. But the way it is here, there's no shaded overlapping region, so there's no solution. Alright, let's come to 5 and 6. So we'll take a look at these two. I'll go ahead and do number 5, and you guys can try number 6 on your own. So for number 5, start with this, the first one. So we got graph 1, graph 2. We can number those if you want to. You can say this is graph 1, this is graph 2. Starting with number 1 here, y is greater than -2. So it's going to be just -2 on the y-axis. So that's going to be right here. Sorry, that's positive 2. That is not correct. -2. I don't know what I was thinking. -2 down below. Just keeping you on your toes, making sure you're paying attention. So we're going to need a line going straight through here, and you can see that because there is no equal to, it's a dashed line. It's like an open whole dashed line. This one is open, so we want a dashed line going along here. So starting with this one. Now, what I'm going to do here, since it can be kind of confusing with the overlapping of the shading, you might be able to do it with a pencil perhaps, but I'm going to just draw both boundary lines, and then I'm going to try to figure out which one is going to be the correct shading. So I'm going to draw this one next. Actually, I'm going to do this one in blue. So number 2 will be blue here. Now this would say +0 because there's no y-intercept, so the y-intercept is going to go through the origin right there at 0, 0. Our slope here, the m on this line is 3, so it's 3 over 1. So we're going to go up 3 and right 1 from that line. We could also go down 3 and left 1. It is a solid boundary line, so we're going to draw a solid boundary line up through here. And also going down. Now remember, you're going to stretch all the way. Trying to get it best. If I use a ruler, that would be even better, but it's hard to use a ruler with this thing. Okay, so there's our boundary line, stretched all the way from one end of the window to the other. So now what we notice here is there's 4 regions. So you got your kind of upper left, your upper right, your lower left, your lower right region. So we want to now see which one is it going to be, is the right region that's going to be the overlapping region, which would be our solution region. So from our first one, number 1, that's the one here, is it going to be above it or below it? So that's the first one you want to talk about, is just, is it going to be above or is it going to be below that on the y-axis? So it says y is greater than -2. So greater than means it's going to be above this. So this is going to be up right here. So that's going to be up. And then y on this one, we want to now see, we know it's going to be up here. So now is it going to be on this side or is it going to be on this side? Is it going to be the upper left or is it going to be the upper right section? So this one, according to this one, says y is less than where 0 is. Less than 0 is going to be down below. So on this one, we would be shading this side over here. The overlapping part then is going to be the upper right region. So this one's going to be upper right. Maybe I'll put upper here and then right. So upper right region is, this is our solution region then. So I'll go ahead and draw my highlighted part here to shade this whole thing. So this whole thing is shaded. That's our solution region. So here's what we can do is we can pick a test point out of here. Any test point would be fine. We can pick 2, 2 if we wanted to. So 2, 2 is an easy one maybe to do. And we can just plug it in here. So this would be, this is our 2, 2 here. And just double check, we should get it true for both of these if this is the correct region. So we're going to start with 2 is greater than -2. That is correct. Yes, and on this one, 2 is less than or equal to 3 times 2, which would be 6. 2 is less than or equal to 6. Yes, 2 is less than 6. So it's correct for both of them. That definitely means that is the correct side or correct region that needs to be shaded for the solution region. All right, so I'm going to have you try number 6. Go ahead and pause the video. Do number 6. Number 6 has a horizontal line, just like we did here on this one, but then it has a vertical line with x is less than 2. So you're going to have one going across and one going straight down. You still have 4 sections to figure out which one of those should be shaded. So try number 6 and then check your work. Okay, you should have paused the video and tried 6. So hopefully you have 6 done at this point. So let's go ahead and look at 6. So I'm going to say, okay, this is my first equation. I'll do in red. This one I'll do in blue. So for the red one, we're going to be at 3. So positive 3 is right here. These are both going to be dashed lines. So dashed line going along here. And before I figure out the shading, I'm going to draw the other boundary line on the same coordinate plane. This is going to be where x is 2. 2 is right here on the x-axis. It's also dashed vertical line though. So again, make your dashed line going up along here and going down. There. All right, so now again, we want to figure out, we have a upper left. Here's our upper right. Lower left is the big section. Lower right. So start with the first one to see if it's upper or lower. So it's based off of this one. So we're going to see that on this one it says y is less than 3. Less than 3 is going to be down here. So it's going to be lower. Okay. So it's one of these two sections. Is it lower left or is it lower right? So based off of this one, it says x is less than 2. Less than 2 is going to be on this side, so it's on the left. It's going to be shading this side of that blue boundary line. So lower left is where we need to shade this big, so the big section is the actual solution section all through here. So all the big section all the way from there to on this side of the blue line and below the red line. This is where the shading is going to overlap. Any point in here should be the solution point. We can pick 0, 0 to try that, and we can figure out really easily. If I put 0 here, 0 is less than 3, that's true, and 0 is less than 2, that is also true. So that, yes, that is the right spot to shade. All right, let's move on to our next one, next 2 problems. So now we're on page 166. So you want to turn the page at the top. number 7, number 8. I'll go ahead and do number 8, and you can guys come back and do number 7. Okay, so for number 8, we notice these are not in slope-intercept form. So to graph them, it's best to put them in y equals mx plus b. Now for 7, they're already in that y equals mx plus b form, so you won't need to do that there. But for this one, the first thing we'll do on the top one, so I'll do again, here's number 1, and then I'll do equation 2 in blue. So for number 1, first thing we want to do is move the x term to the other side because we're trying to get y by itself. So now these two cancel, and we got 3, put it up here, 3y is less than, I'm going to put the x term first, negative 2x plus 6. Divide now by 3 to get y by itself. We have to divide each of these separately by 3. So cancel out those 3's. So now this one's going to say y is less than negative 2/3 x, and then 6 divided by 2, or 6 by 3 is a 2. Okay, so for our first boundary line, 2 is the y-intercept. So we're going to put a point right here at 2. Slope is the negative 2/3. So we can go down 2 and right 3. So down 2, right 3 puts us right here on the x-axis. I can do the opposite. I can go up 2 and left 3. Puts me on the same trajectory of the same line. And for this one, we want to notice, is it solid or is it dashed? And we can see it's dashed because there is no equal to line. So we do need to put a dashed line through here. So let me see if I can try to get my dashed line going. Put the arrow on that side and coming up this way. Okay, so there's our boundary line for the first inequality. Now we'll draw the boundary line for the second inequality. In this one, all I need to do is add 1 to both sides. So for this one, we're going to see it's going to say y now. These 1's cancel, is greater than or equal to x term first, negative 2x plus a 1. And the 1 is the y-intercept, so it's going to start right here. Slope on this one, m, is negative 2 over 1. So down 2 and then right 1. Down 2 and right 1. We can do it again, down 2, right 1. I can keep going as long as I want to, the whole window through. I can go the opposite direction, up 2 and right 1. Or left 1, sorry. Up 2 and left 1. See, all the points will line up that way. And this one, it's solid, so we're going to draw a solid boundary line here. So let's put a solid line going through all this. There we go. Okay, so now again we have 4 regions. So we have the upper left region. This is the small little region right up here. This little tiny region, upper left. Upper right region. Our lower left region is like the big region, and the lower right region is this kind of thin area here. So for equation 1, we want to see, okay, looking at now, not looking at these, you want to look at when you have it in the y equals mx plus b. It's easier to do it in that section, so I'll do that green here. So for this one, if I put 0 here, it's going to go away. Y is going to be less than 2. So less than, y is less than this 2, but it's going to be going down here, so it's lower. So it's lower. And then for this one, on the blue one, if I put 0 here and that goes away, it's y is greater than 1. So greater than 1 is going to be, so now it's going to be lower, so it's either going to be the lower left or the lower right. So on this one, greater than 1 means I got to shade this side over here, so the overlapping part is on the lower right. So we're going to be on the lower right section. That's this section right down in here. So all of this is what's going to get shaded. And we can pick a test point out of this region just to double check. So a test point, try to pick an easy one. I would pick maybe right here. This is a fairly easy one, which would be 1, 0. 1, 0 would be that test point. And we can check it either back in our original, that's fine, or you could check it over here, but maybe the originals would be even better. For the top one, if x is 1, that's going to end up being 2. And then this is going to be 3 times 0, so that's going to be 0, so 2 plus 0 is less than 6, which is basically 2 is less than 6, so yes, that's true. And then for the blue one, we can see if I put y first, that's going to be 0 minus 1 is greater than or equal to negative 2 times 1, which is x, that's negative 2. So this is going to be basically negative 1 is greater than a negative 2. Yes, that is true. They both check out, so that definitely tells us that that's the solution section, the solution region. This is where they would definitely overlap. All right, so go ahead and pause the video now and try number 7. See if you can do number 7 and get the correct solution region. You want to draw the two boundary lines first and then figure out which section, which of those 4 regions is the solution region to shade. So go ahead and do that and then check your work once you're finished with it. All right, so you should have done number 7. So you should have paused the video and done 7. So these are both in slope-intercept form. Again, I'll say this is equation or inequality 1, inequality 2. And so when I graph my first one, we're going to start with negative 2. So negative 2 is down here. Won't make that mistake again. And our slope is 1. So this is going to be slope of 1. So m equals 1 over 1. So up 1, right 1. Up 1, right 1. And we go down 1 and left 1. And so now we want to check out, so that's the first one. Now it was a solid boundary line, as you noticed on that one. That's why I did a solid one, didn't do a dashed one on that one. Let's try our blue one here. So we're going to start at 2 for this one. So this one's going to be at 2, positive 2, right up here. And this one's got a slope of negative 1. There's a 1 in front there. So negative 1 over 1, rise over run. So we're going to rise, actually we're going to go in negative direction, down 1 and then right 1. We can keep doing that, keep doing that. If these were equations, you can see this would be the solution point if it was an equation. Remember, if these are equal signs, the point of intersection is the answer. But when they're inequalities, it's the intersecting region. It's the shaded intersection part. This one's dashed, so we're going to do dashed line through all of this. So I'll go and just put a dashed line through each of these points that I made. So the whole thing is dashed here. Now we need to decide, okay, is it going to be, this would be our upper, now so it's kind of hard to see maybe because of the X here, so you almost have an upper and left here, but you have kind of an upper left, upper right, lower left, lower right on this one. So for our first one, I'll do orange on this time. So our first one here, this is our blue, our red one. So is it going to be above it or below it, upper or lower? These are the two upper sections here. These would be the two lower sections. So based on this, y is greater than this, greater than negative 2 is in the upper section. So this is definitely upper here. And then, so it's going to be either upper left or upper right. So according to this one, y is less than the 2. Less than 2 is on this side of it. So this side is going to be on the, I'm sorry, I'm looking at the wrong line. We already did the red one. Look at the blue one now. So less than 2, less than positive 2. So that's going to be down over this side. So it's going to be the lower left section. Upper left, sorry. I'm getting myself confused. So upper were these two. It was on the upper one from equation 1. So it was above on the red line. And then it was for the blue line, this blue dashed line, it was actually down over here between on this side. So that's going to be over here's where our shaded section would be, our one that is overlapping. This is the overlapping region. So this is our solution section right in here. All of this. And we would want to pick a test point. Easiest one to pick is 0, 0. So right there, 0, 0, we could pick that one. And if I test at 0, 0, that just means we can say if 0 here, it's going to be basically 0 is greater than -2, which is true. And on this one, 0 is, because it's 0's here down 2, 0 is less than +2, which is also true. So it works for both of these. This test point at 0, 0 is definitely a solution. That's definitely the correct region that you want to check and want to graph. All right, well, in the next section, we're actually going to be doing this in reverse. It's going to give us the graph, and we're going to have to write out the inequalities. So let's take a look at that section, and then we'll be done. Before we get to that section, let's go and look at our joke of the day. Sometimes he sneaks up on us. Here we are on our joke of the day. So here it is. Why did Cinderella get kicked off the soccer team? Was that sportsmanlike conduct? Was she bringing her mice to the soccer match? Were they running around? Why did she get kicked off the soccer team? Well, because she ran away from the ball. Oh, that's it. Of course, she always runs away from the ball. Now she loses her soccer cleat in the process. All right, moving on to 9 to 12. So write a system of linear inequalities represented by the graph. So like I said, it's going to show you the graph. We now need to write out this system. So we need to look at each one of these. So I'll go ahead and do a couple of these. Maybe I'll do, I got a couple that are like parallel ones in here. So there's a couple of parallel ones. Here's one that's just regular, just vertical or horizontal lines. Here's ones that are just going to be y equals mx plus b lines. So let's go ahead and take a look at what we'll do here. So these ones are both vertical, it's horizontal. We got one of each on this one. So maybe I'll do number 9, you guys can do 10, and maybe I'll do 11, you guys can be doing 12. Now, so number 9, let's number these lines here so we can see which one we're talking about. So I'll number this one number 1. And I'll number this one number 2. So number 1, number 2. So I'll put it over here. Number 1, equation 1 is going to start with y. We're going to write these in like slope-intercept form as best we can. Where is this going through? It's going to be y because it's going through the y-axis. It's going through right here at 3. So it's going through 3. So we know it's going to be 3, but now there's going to be an inequality sign in between the y and the 3. Where is the shading? So you can see obviously the shading is not above it, it's below the line. So it's definitely less than. It's definitely less than. And this one, it's kind of hard to tell, but that actually is a dashed line. It is very hard to tell. I messed up the first time I looked at it, but now I noticed right here, you can kind of see it a little bit better right in here. There are some dashes on that. So it's just less than. So there's equation 1. Or inequality 1, inequality 2, this one going, we can definitely see that one's dashed. But it's going to be an x on this one because it's vertical. So this one's vertical because it's x because it's vertical. Where is it going through the x-axis? Right here at 2. So it's going to be 2. There's going to be an inequality between those two. And this one, the shading is not over here, it's on this side, so it's less than. This one's also less than, and we definitely see it's a dash, so there is no equal to line. There's our system. That would be it. So that's the answer. Let's go ahead and do number 11. So number 11, let's number these also. I'll say this one is number 1. This one will be number 2. So number 1, we can see this number 1 is dashed. I'm going to start off with y. Any vertical line, any diagonal line, is going to be y, and then the inequality sign. But before we do the inequality sign, let's do the mx plus b part. So it might be easier to start with the m and the b. This is for number 1. And maybe I'll put that up above here. So m and b. So what is m and b for number 1? So b is right here at 1. So b is 1. What's the m of this dashed line? Well, you can see it's going up 1 and left 1. Up 1, left 1. That's a -1 slope. So -1 is the slope. So it's going to be -1x, or we can just say -x, and then positive 1. The inequality sign that's going between that, okay, so you look over here, it's definitely not shaded on this side, it's shaded below that, it's less than the -1, so it's less than sign. Okay, for number 2, again, we want to find m and b. For number 2, we'll start with the y. So let's see, b for this one is the same point. That would be the actual solution if it was equations, but these are inequalities. So this is the solution region, as you can see right over here where it's darker. So this is also 1, but this one is going up 1, right 1, up 1, right 1. That's got a positive 1 slope. So it's going to be 1x, or just x, plus 1. And then where is this one going to be shaded? As you can see, it's not shaded this way, it's shaded above. So it's shaded above 1, so it's greater than 1. And it's also a solid line, so we're not just going to say greater, we're going to say greater than or equal to. All right, go ahead and pause the video, and I want you to try number 10 and then number 12. Number 10, they're both lines are horizontal, so they'll both be like the first one here where it says y. And then this one, they're diagonal, so they'll be more like these guys. So do number 10 and then do number 12, and then play the video again to check your answers. Okay, hopefully you've got number 10 and number 12 completed, and you're just checking to see, did you do these correctly? So I'm going to number these ones here, so I'm going to say this one's number 1. It doesn't matter how you number them, so if you number them opposite, that's fine. But for number 1 here, it's going through right there on the y-axis. It's going through 3, so it's going to be a y, and it's going to be a 3. Where is it shaded? So for this one, because these are parallel lines, and it has a shading right here. The overlapping part is in between them. So this one's obviously not shaded up here, and this one's down here. This guy is shaded down below, so it's shaded down below the line. So this one's less. It's less than 3. But then for number 2, when I start with the y, and then the number here is 1. And again, it's hard to see this. It does look like a solid line. It actually is a dashed one according to the answer, but if you put that it was solid because you thought it was solid, that's fine. They made this really hard to see that that was supposed to be dashed right there. I think it's because it's overlapping with the shading. But for this one here, we can definitely see it dashed, and it's 1, and this one is going to be shading above it, so it's going up above, greater than that, so it's like that. So y is greater than 1 on the second one. So those are your two inequalities that you should have. And if you did put an equal to on this one, that's fine if you thought it was solid, if you thought it was a solid line. Because if you thought it was solid, then you would want to put definitely that it's equal to. Number 1, I'm going to use number 1 on this one here. This will be my number 2. So that's definitely dashed. Where is it going through? It's right here at -2. So number 1, it's going to put a y. Again, we're looking for m and b. So the m and the b, we can see b is -2. M on this one, up 1, left 1, up 1, left 1, so it's a -1. So it's -1x, or just -x, and then -2. And this is going to be shaded since these are parallel lines also, and your overlapping part is in between them. This one's got to be shaded up above, and this one will be shaded down below to overlap. So if it's up above it, it's greater. So greater on this one. And then for number 2, start with the y, the m and the b. So the b on this one you can see is right here, which is at +1. And the m on this one is up 1, left 1, same slope as the one above it. It's a -1. So it's also like -1x or -x, but then it's +1. And like I said, this one is going to be shaded the opposite way. It's going down below in order to get the overlapping section in between. So that's going to be less than on this one. So less than, and it is a dashed line. That one you can kind of see. I definitely see that that's dashed. So those are your two inequalities for number 12. All right, hopefully you were able to get those correct, and you should be ready to do your assignment now from this. All right, this concludes our last lesson in chapter 5. So the next time I'll see you would be on chapter 6. So have a great time. Until then, have a great day, guys. Take care.